All right, so we left off motivating a spending multiplier. So that's where chapter 11 takes us, is into one of the motivations of the government spending some money would be that the money just seems to get spent over and over. And if we look at our circular flow model, the government jumping in with some spending, buying weapons of mass destruction, ends up going into somebody's wallet. That person runs to Walmart. Walmart pays its employees, right? So spending leads to other spending. And this is true with kind of like outside money coming in. So we have two types of spending we're going to look at: autonomous spending and spending or expenditure. Multipliers. So somebody's into business employees, among other things, employees and resource support in turn on and so on and so on and so on. So we've got two types of spending we're going to look at. So got expenditure, and induced expenditure is spending that varies according to your income. So spending that is induced by income. You get a paycheck, you go out and spend it. And so we could, assumption that we do, go to Walmart, go to Apple, run into Lowe's for some home improvement stuff. Part of our consumption comes to us from our income, and part of it could come from somewhere else. So we've got two of a formula that looks like this. And so part of our money that we use for spending might come to us in the form of a gift, and this is called a consumption. And little b here is the fraction in for consumption, which is the MPC. I think I defined before. We're going to do it again. Does anybody remember what that was? Marginal propensity to consume. Looked at that back in maybe the savings chapter when we started thinking about what we. And so that's the. All right, so that there's no that one of your topic on the fair tax was abolishing income tax. Not to say that we're going to live on taxes, but we're going to collect taxes on at the cash register. What that would mean is that without any taxes on your income, if there's no taxes, extra blurb here. Assumption. Equals YD. Back to what we did before. Not our consumption function. I can't remember if so I don't even remember what they were doing. Was that spelling or conjunction for sentences? Yeah. So we got consumption function here. Consumption function. All right. So somebody gives you some money, you earn some money, all of it leads to you running to the store. What is that function? Starts somewhere up here because we. If this was $100, and you're going to consume 90% of the $10,000 of money that you have, you're going to consume $100. So, a nice little slope-intercept form where the vertical axis here is A. The consumption. Okay, so that is what we mean by induced expenditure. Of expenditure we've just looked at briefly, or in autonomous. Is spending on income. So if we ignore the rest of the world, and we've got GDP being partially composed of consumption, but what else is in the expenditure approach to measuring GDP are cigarettes, investment, government spending. Dump those into this category and say that those do not depend on income. So we've got but the component here would be investment and government. So if investment equals 50 million and government spending equals 75 million, what would the I function look like in this space? So if I was to graph I here and Y here, what would that look like? Straight line. So at $50 million, that function is really no function at all. It's just income is this much, it's 50. Income is this much, it's 50. Income is this much, it's 50. So it's always constant. It's autonomous compared to different levels of income. And G is the same way. If I'm measuring how much government spending, we're at 75. The G function would look like that. So the G function, I think, is potentially even easier to think about. So the government is choosing to spend 75 million, and it doesn't vary according to income automatically anyway. It's at their discretion. So if I now start to think about this in a bigger picture, instead of just consumption spending, I think of all spending. So if I start thinking about aggregate expenditure, if I think about aggregate expenditure, I'm going to put all those components together. So if I've got aggregate expenditure equals C plus I plus G, let's ignore the rest of the world for now. What does that start to do to our line? If I add 50 million to the picture and I just break it down slowly and I say, suppose we look at C plus I. What happens to this function if I look at now the C plus I function? Goes down? Up? Up, right? So I'm adding on 50. So really, this new line here would be A plus 50. And since it's independent of income, the increase of spending would continue up at the same rate. So it would be a parallel shift up, essentially, by that vertical distance of 50. And now, hopefully, you're starting to get the feel. If I now add government spending on in the same fashion, we've got 75. A plus 50 plus 75 gives me a new intercept. And now I've got C plus I plus G. Okay, so we're starting to separate how people spend money and what production is of output in the economy. One of the things Keynes brought to the table, which was insightful, among other things, even though I might disagree with Keynes on a variety of things too, is the idea of inventory. This lag time between build it and they will come, right? So we make something, we hired some people, we put them to work, and then we hope to sell it. So there's a potential difference between production time and sale time. Now places like Walmart have been famous at shortening that, right? Their inventory turnover system that they developed with their software was kind of instrumental in them growing into the big giant, retail giant that they are today. That was kind of held under lock and key by Sam Walton for a number of years. So they wanted to have something come in the morning and sell it in the evening. The shorter time that they can make that, the better off they are. Well, that's how we're going to look at inventories now with this model. All right, so this is the aggregate expenditure model. Aggregate Expenditure Model. I'm going to make it a little bit bigger this time. Over here, we're going to measure planned aggregate expenditures, planned spending versus our income. So we got real GDP, similar to measuring our aggregate demand, aggregate supply. I mean, it's the same variable down there. We'll tie these things together later. And because of autonomous components to spending, we have an aggregate expenditure function, which is really our C plus I plus G, that looks like that. All built upon what we did here. All right, so in equilibrium, the amount of stuff that's being produced, so now you can start to loosely thinking about this being the amount of production, is equal to how much is being spent. And so we use a 45-degree reference line. A 45-degree reference line, mine's a little curvy there, but and all points along this curve show what between spending and production? Where they're equal. So if we're at 1,000 units here, then that means there's 1,000 here. And so the interesting things in econ tend to happen where the two lines cross, and so you might have guessed it, that's some sort of equilibrium where spending equals production. And so let's just call this AE1. All right, so markets don't always clear right away. And so this gives us a little bit of insights on inventory. One variable that might have snuck up on you that you haven't paid too much attention to, because we tend to focus on businesses buying machines and equipment. There's a couple other things that were in the I category. Does anybody remember? One of them dealt with households. So households, homes, brand new homes, not used, I bought a 1972 home on Cedar Street type of home, but brand new construction homes, those are actually part of I too. So those are part of what we can put into the category of investment for the economy. And then the other thing that's in there is inventory that's not been sold. So all of the stuff on the shelves at Walmart that is still yet to be sold or waiting for you to come in is finished goods inventory. And you can imagine if we start adding up just even the value of the inventory in Ottawa, it would be kind of mind-boggling. I'm doing some work at one of the lumber stores in town, and he carries about $600,000 worth of inventory in his little store in Ottawa. $600,000. One little store in one little town in Ottawa, Kansas. So imagine the inventories that are being held in the city of Ottawa, the state of Kansas, the United States of America. There's a lot of dough tied up in inventory. So how does that play in here? Well, if production ramps up to here, where we're out of this equilibrium situation, so we're kind of telling a disequilibrium story. At this level of income, people are planning to spend this amount is the level of planned spending, and here's the amount of output. So what's happening with goods on the store? Do we have a surplus or a shortage? So the level of output out here is kind of this height, if you will. That's why the 45-degree line kind of helps us. Is there excess goods being out there or a shortage? Excess. So if I had numbers on this thing, it might help. So let's just say, I guess I'm using 1,000 there, so let's say this is 5, 6, 7, I don't know, let's call it 700. So at 700, that means this height is 700, so this must be a 700. So production is at 700, but spending is at something. So people are spending less than what's being produced. And so what's happening to the inventory on the shelves at Walmart? Is it going up or down? It's going up. So this represents a surplus. And for this part of the story, the surplus means an increase in inventory. Now we got a couple things going on. If Walmart starts to have excess inventory, what will they tend to do? Lower prices. And so the value of the inventory, the value of the sales might fall because of that point. And are they calling up the phone to all of their vendors and all their suppliers and ordering more and more and more? No. They say, whoop, I know I ordered 100 last week, we only need 50 this week. So when we're in a situation where inventories are piling up, producers quit producing and they reduce their inventory. So when we're at this point, we're going to tend to drive back towards this equilibrium. Now on the flip side, if it comes too far and we go to, let's call it Y3, this is the amount that's being produced is, let's say 200, but the amount that's being spent is 400. So spending is going on at 400, production is at 200. And you might say, well, how can we buy more than what's produced? What's the answer to that? How can we buy more than what's produced? This is what's kind of slippery about this topic.
So this surplus from previous years, that's included?
Kinda, yeah, that surplus is the current inventory. So there's a current amount of inventory on the books on the island as we sit. And so Walmart normally keeps 10 things of Tide detergent, and now persistently they're only down to 3. They can't keep inventory in there. So there's some room to suck up that excess purchases, that excess spending. But what we see in a dynamic sense is that this distance here represents a decrease in inventories. So inventories are falling. I want to put that a little more dynamically, I guess. Falling inventory. And this one was increasing rather than just up inventory. So inventories are increasing in this case. Inventories are falling. Walmart calls up the phone, hey, things are flying up the shelves. Let's ramp up production. We've got to get these plants going, right? And so we tend to move back towards here. So this is all kind of an argument for why we expect this to be equilibrium. So let's note that down here. So at Y2, inventories are increasing. So businesses slow down or reduce production, which might mean laying off some workers. It might mean something to adjust for that. And So conceptually, we're moved towards y1, which is our equilibrium. At y3, inventory is falling. And this signals business to increase production. Again, move towards y1. So this inventory acts as a signal to businesses. And that's one of the things that helps us reconcile how we can go through swings too in the business cycle. All right. Now we're going to talk about shifts. So what happens if the government increases spending by 50 million? So if we increase government spending, or we could have done investment, it doesn't really matter which one we do, but the increase of 50 leads to an increase in aggregate expenditures by 50. The shift up, we'll do the shift in a bit, which leads to somebody having an increase in income of 50. That change leads to an increase in consumption equal to all of the 50. If you get income of 50, are you going to spend it all? You might, but on average, there's only going to be the marginal propensity to consume times it. So if the marginal propensity to consume is, use 0.8 here, if people consume 80% of their income, 10% is $5, 20% would be $10, so there's an increase in consumption of 40. They go out and spend that 40, and there's an increase of consumption equal to 0.8 times 40. So we get $32 worth of spending. That $32 goes into somebody else's pocket. And so the amount of change in income that this change in government spending, so the change in G was 50, led to somebody having more income, somebody spending that income, somebody spending a fraction of that income, and so on and so on and so on. So that's our multiplier effect. A change of 50 led to 50 plus 40 plus 32 plus all the way down the line. So graphically, let's draw a new one. Draw this one kind of flat. Just kind of helps see the picture here. 45-degree line. We start here. And we shift up. This is at G1, and this is at G2, or let's call it G1 plus 50. Whatever we were at before, plus 50. So in your homework problems, you might be given currently government spending's at 200, and now it's at 250, so it shifted up by 50. Graphically, this is the way it's looking. And so output goes up by 50. But if you take this and drop it down, income went up by more than that. How much more depends on the multiplier. So the change in y, the change in g equals 50. What is the change in y? And for that, we have a nice little shortcut. The change in output is equal to 1 over 1 minus the marginal propensity to consume times the change in autonomous expenditure. So plugging in our numbers, our marginal propensity to consume was 0.8. 1 minus 0.8 is on the bottom, times the 50 million spending. One over 0.2 times 50. What's the multiplier? 5. So the multiplier is 5. 1 over 2/10. Pull out your calculator. 1 divided by 0.2. Whatever you need to do, or 1 over 2/10. Flip that over. 10 divided by 2 equals 5. So this is the multiplier, the spending multiplier. And it's a very simplified version of it. And so the change equals 250. So a $50 bump in weapons of mass destruction leads to $250 worth of economic activity, is what the argument is. So that's a good thing to do, in theory. Did you see it? No? Okay. Okay, so a couple notes I want to make. this is the simple, very simple, but the most simple multiplier. What makes it simple? No tax, no imports, so no rest of the world taken into account. But no imports. No imports. Now, the most important effect's not even on there, and that is thinking about the price level. But that's a secondary thing. So no tax, no imports. All right. Questions on that? I know this part's a little bit boring. Gotta crank through some of the math. Hopefully we'll get to some more excitement here shortly, but this one we gotta just kind of work through the guts of it. So 50 unit change here leads to a 250 change here if you want to add on to this graph. So that is the bump up in output we get through spending. So, aggregate expenditure, C plus I plus G. And if we wanted to make this a little more fancy, all I want to do is motivate what the real multiplier has in it. That's a little more complicated. So there's our cigarettes, just like we've been used to. And let's put down the pieces of the puzzle. What is some number plus the marginal propensity to consume times our income minus our taxes, if we think about the complicated version, disposable income. Plus investment, plus government spending, plus exports minus imports, where we're going to add what we buy from the rest of the world and subtract what we import from the rest of the world. With our marginal propensity to import, maybe we don't like those foreign goods as much as American goods. Maybe it's the same as our MPC, but we potentially have a marginal propensity to import that could be different. If some other people are all about buy American, then they might not want to do that. Minus T times Y. So there's the big ugly monster. And if you take your pencil, even if you're doing the same, we can start to break down which one of these are numbers and which aren't. So autonomous part, I meant to kind of do a different pen here. The autonomous part, autonomous, autonomous, autonomous. And then we've got Y, 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 Y. So if we did some mathematical manipulations, which I'm not going to bore you with, we could boil this thing down to some number plus this expression. The marginal propensity to consume times 1 minus T. You guys can look in your appendix if you want to see where this thing exactly comes from, times Y. And that is the ugly aggregate expenditure line. But it's really the same thing. it's in slope-intercept form. The ugly part here that has a mixture of the tax rate and these other components, that's the slope. This is the intercept. And so we've just got slope-intercept form of a line, and of course y is our horizontal axis variable. All right, so the toughest we're going to challenge you guys with in your homework is to not expect you to know that big ugly mess, other than it is a mess. And quite frankly, there's probably some macroeconomists that would think we're onto something, but most modern macroeconomics would probably throw a lot of this out the window with some of the multiplier business. And this is the one you need to know. The real world multiplier is 1 over 1 minus the slope of aggregate expenditure. The simple one I gave you was 1 over 1 minus the MPC. The sophisticated one is 1 over 1 minus the slope of the AE, which is really the same thing. If I assume no taxes, no government, and no rest of the world, then that's all we're really doing. So this is the multiplier you'll see used in your homework. And so this is the autonomous expenditure multiplier. So if there's a graph that shows that line, just calculate the slope and you'll have that multiplier business figured out. So one other variation of that. So in fact, let me put this one down here, just rewrite it. This multiplier, the simple multiplier, could be restated as 1 over 1 minus the MPS. What the heck's the MPS? Marginal propensity to save, and I bet that's why Chelsea's hand was going up. 1 over that. Because we are either saving our money or consuming our money. If I consume 80%, I'm saving 20%. So I'm either doing kind of one or the other. So that's a little thing you might see on a problem too, be able to go back and forth between that. You get to the same spot. So the reason we have that is we're going to consume 100%. The marginal propensity to consume plus the marginal propensity to save have to sum to 1. So from our example, we had 80% plus 20% equals 1. Okay. Our next step is to tie that to the aggregate demand, aggregate supply. And then we'll just about be wrapped up. But let's take a break.